So this question was explained on the practice quiz, and there's many roads to the same place, like we've been saying, and it wasn't the quickest path, the way I explained it on the practice quiz, so I want to re-explain it right here. We know that when you're multiplying terms with the same base, like x to the second times x to the third, what do? We add those exponents and get x to the fifth, right? We know that rule. So if you notice, on this question, all of the items that have an exponent, rational exponents, they all have the base x, and it is all pure multiplication. So we could, the way I did on the first recording, multiply these two x's together, which would imply me adding 1/2 with negative 3/4, which would be a simple question of getting a common denominator and so on and so on. But then we got an answer, and then we had to move it up, right? And then we had to combine this one with that one. So we could move all of them to the same place, move it up, and that'll become x to the positive 3/4. Move this one up, and it'll become x to the negative 1/2. And of course, the 4 stays down here. So what do we really have here? We have x times x times x, and we have different powers on all of them. So what do we have to do with those powers? We're obviously going to combine the negative 1/2 with the positive 3/5 with the positive 3/4. So our question becomes this addition and subtraction of fractions. The negative 1/2, the positive 3/5, and the positive 3/4. Okay? So in order for me to add fractions or subtract them, I need a common denominator. What's the common denominator going to be? 10? 12? 15? 20? Right? So you want to think, what number could I change all three of these to? Now, if you say 10, yeah, 2 and 5 work, but 4 times what gives you 10? It doesn't work. If you say 15, well, the 5 will become 15, 5 times 3, but you can't change these to be 15. So obviously 20 is the first number that all three of them work. So I always rewrite my common denominator down here of all three fractions, okay? And I ask myself, how do I change this 2 to become a 20? Well, obviously you multiply by 10. So you're going to multiply this top number by 10, and it'll be a negative 10, because up there you had a negative 1. Negative 1 times 10 is negative 10. And then you have plus. How do we change the 5 to become a 20? Well, we have to multiply by 4, so multiply by 4, and you will get a 12 up here. How do you change the 4 to become 20? You multiply by 5, so you multiply by 5. You end up with 15 right here. So, of course, now we're able to add those three fractions that have all the common denominator of 20. Okay, so what is negative 10 plus 12? That ends up being positive 2. And what is positive 2 plus 15? That ends up being 17, right? So what we have is the answer 17 over that common denominator 20. And remember that this problem right here, this fraction, is really the exponents all combined together, and it should be over a single x. So I should have my answer a single x to the 17/20th power over what was left on the bottom. Well, we moved that up. The only thing left on the bottom was a 4. So that is our answer right there as a rational exponent. So that wasn't that bad, right? On the practice test, I did it a different way. Like I said, there's many roads to the same place. I actually combined these x's first, and then I got an answer. Then I moved it up, and then I combined those x's. So it took longer. Right here, this is the answer in exponential form. The only other thing you could do is to change it to radical form, which I prefer, and you're going to see radical form more than exponential form on the quiz. So that would be the 20th root of x to the 17th all over 4. Okay, the 20th root of x to the 17th all over 4. So on today's post, we did put this worksheet on there. This guy right here is very similar to the one that we just did. Shall we? So what do you think would be a good idea to do on this one, based on what we just did on the other question? Move them all to the top, right? Okay, now, and you don't have to move them all to the top. You could move them all to the bottom. But we are going to move them all to the top on this one, because when I move this one up, it'll become t to the to the negative 1/2 power. Okay, the 5 obviously stays down there. It didn't have a negative exponent. And then I move this one up, t to the positive 3/4 power. Okay. So we really do have t times t times t, and we just have these different powers, the negative 1/2, the positive 2/3, and the positive 3/4. So when you're multiplying with the same base, you really add those exponents. So it becomes a simple addition subtraction problem of fractions. So I have the negative 1/2 plus 2/3 plus 3/4. So let's look at that denominator. The denominator is 2, 3, and 4. What's the common denominator, the lowest common denominator? 12. That's right. If you are rough on the edges on finding that least common denominator, guys, go to the biggest denominator and ask yourself, could I change 2 to become 4? Yes. Could I change 3 to become 4? No. Right? And then double it. 8. Could you change 2 to become 8? Yes. Could you change 3 to become 8? No. And then times 3, 12. So, and then you see, 12, all of them could be changed to 12. So yeah, that common denominator will be 12. So I'm going to write 12 3 times underneath fraction bars. Then I ask myself, how do I change the 2 to become 12? I multiply by 6, multiply by 6. I'll have a negative 6 up here. Of course, we have a plus sign in the middle. And then I ask myself, how do I change 3 to become 12? I multiply by 4, multiply by 4. I'll have an 8 up there. How do I change 4 to become 12? I multiply by 3, I multiply by 3. I have a 9 up there. Of course, with another plus sign right there. So now we're able to, now that we have a common denominator, I could just add the numerators. So what is negative 6 plus 8? That's 2. 2 plus 9 is 11. So my answer will be t to the 11/12 power over 5. T to the 11/12 power over 5. Obviously, as a radical, this would be what? What kind of root? 12. The 12th root of t to the 11th power all over 5. So again, this is the most direct path, the quickest path to the answer. But of course, it could be done many other ways. Like I could have decided to, I want to multiply this t to the 1/2 times this t to the negative 3/4. So I could have done the math, 1/2 take away 3/4, get a common denominator, do that math, and then get that single t to a certain fraction power, and then move it up, and that, but it's a little bit longer. So I did explain the quickest path right here. Move them all to one side, and that should be pretty easy to find a common denominator for 3 fractions, add or subtract them, and you will be at your answer. One other warning, guys. Let's say you did move, we did move them all up, right? But let's say when you did the math, adding and subtracting those fractions, let's say you would have ended up with a negative down here, or up here, a negative fraction. Then you'd have to take that term with the negative exponent and move it down. You guys remember that? Because negative exponents, you have to move them to the other side and make them positive. And then if this was a negative and you did move it down, then you'd have to get rid of that rational exponent. You know what? Let's go to a homework problem that actually happened like that. So here's a question on yesterday's homework from the book. Now this it might be overkill. I mean, I'm doing 3 different types of problems that are almost exactly the same, and there's only one of these on the practice quiz, one of these on the test. But I mean, it's still good. These are one of the more entertaining questions. So what could we do on this one? Move them all up, right? So if you move the f to the negative 1/2, or f to the 1/2 up, it'll become f to the negative 1/2. And then if you take this one and move it up, then it'll become times f to the positive 1/3, right? Whenever you move them from one side to the other, the sign changes. So what we really have is f to the negative 1/2 times f to the negative 1/4 times f to the 1/3. And of course, when you're multiplying with the same base, right, you have to add those exponents. So what we're really doing is adding this exponent with this exponent with that exponent. So it just becomes an addition subtraction problem of fractions. So I'm going to do that up here. So we have the negative 1/2, the negative 1/4, and the 1/3, and we're adding all of them together. We need a common denominator. What's that common denominator going to be? 12, that's right. So let's put a 12 right here, a 12 right there, a 12 right there. How do I change 2 to become 12? I multiply by 6, so I multiply by 6. And we will get a negative 6 up here. How do I change 4 to become 12? Times 3, I get a negative 3 up here. And then how do I change 3 to become 12? I multiply by 4, I get a 4 up here. So we need to combine all those numerators. Now that we have a common denominator, the answer will be over that common denominator, 12. So the question is, what is negative 6 plus negative 3? That's the negative 9. And then negative 9 plus 4 is what? That's negative 5. Now that does not work out so great for us. Check it out. We end up with a negative 5 over 12, and this is the exponent of the f. So on our answer, we have f to the negative 5/12. Let me actually write it in red. Negative 5/12, okay? Over 4. Now, the problem here is that we have a negative exponent, and we can't leave it a negative exponent, right? So what could we do here? We have to move it down and make it positive. Anything with a negative exponent, you need to move it to the other side and make it positive. So I'll have an f to the positive 5/12. All right, so there's nothing left up on top. Imagine there's a 1 up here, and you moved it down. All you have is 4f to the positive 5/12. Now that's another problem. Why is that another problem? Because you do not want a root in the denominator, or you don't want a rational exponent in the denominator. So I'd have to get rid of that f to the 5/12 down there. So I need to multiply both top and bottom. You know what, just to clear things up, I'm going to rewrite it. 1 over 4f to the 5/12. I need to multiply both top and bottom by f to a certain power, both top and bottom by f to a certain power, that will make this whole. So f to the what times f to the 5/12 would make it whole, which technically means 12/12. 7 over 12, right? So we need to put a f to the 7/12 right here, f to the 7/12 right there. So when I multiply this f, okay, so when we add the f to the 5/12 with the f to the 7/12, that will become f to the 12/12. So our answer in the denominator, we have this 4, there it is, and we have f to the 12/12, which is pointless, right? Because 12/12 is really 1, and 1, you don't even need to show it. So that was the goal of multiplying by f to the 7/12, to make it a nice f without a rational exponent, without the 12th root. Now it's just a regular f. And up on top, we have 1 times f to the 7/12. That is f to the 7/12 up here. Now, as a radical, the final answer will be the 12th root of f to the 7th over 4f. F as in fun. Oh yeah, okay. So anyways, we did 3 different types of questions that were very similar to each other. And these are probably one of the most confusing ones. And if you understand it, that's awesome.